All right, we're going to take a look at quadratic functions. So these are our U-shaped graph, or what's called parabolas. And they're in the standard form when it's listed as y equals ax squared plus bx plus c. And of course, if the a is positive, then it opens up. It's going to open up. If a is positive. If the a is negative, it's going to open down. And if it opens down, of course, the vertex would be at the top instead of the bottom. So we've played with our vertex, or here's our vertex form. Here's our vertex form. And we'll get to playing with that. And HK is where that vertex is. So the vertex is at H, that's the HK in that equation in vertex form. That A there still tells you the same thing. So again, if A is positive, it opens up. If it's negative, it opens down, and so on. So same thing for the A in that form. Okay. So let's go ahead and put this in. So if you're looking here at this first one, I'm going to go ahead and write my vertex form here above it. And here's the one we have, negative 2x plus 3 quantity squared plus 8. If you notice, let's identify first of all our vertex HK. So notice it's x minus h, x minus h. So I'm going to write this as x minus negative 3. That's the same as x plus 3. So that I notice my h has to be negative 3. My h is negative 3, not positive 3, negative 3. So x plus 3, it's actually the opposite of the plus. It's negative, right? If you see that. And then our k goes right along with the symbol there. It'd be a positive 8, negative 3, comma 8. So there's our vertex. I'm going to put that on the graph. Negative 3, 8. So negative 3, 8. Oh gosh, negative 3, positive 8. What am I doing? Negative 3, positive 8 up there. Sorry, not negative 8. Negative 3, positive 8. And then notice also our A value. Our A value is that negative 2. So note A is negative 2. In other words, it's negative, so it's going to open down. So it's going to be, instead of U-shaped, it's going to flip it over. And it's going to be like that, right? The parabola is flipped over. But let's go ahead and find our axis of symmetry. The axis of symmetry lies on the vertex. So it goes right down the middle of the vertex. So I'm going to do it in black. There's the axis of symmetry. If you have vertex form, it's x equals h. The axis of symmetry in standard form, if you have this form, ax squared plus bx plus c, then the axis of symmetry is x equals negative b over 2a. We'll do some in that form later. So in this case, we already know the middle of the graph is on the vertex, so it's x equals the negative 3. And again, you draw that dotted black line. And then from there, you can plot some points. Okay, so I like to, once I know my vertex, which is negative 3, 8, it's always nice to plug in a couple to the left and to the right of negative 3. Well, to the right would be negative 2 and negative 1, right? So if you plug in negative, let's go to the left, plug in negative 4 for x, you get negative 1 squared is positive 1. Negative 2 times a positive 1 is negative 2. Negative 2 plus 8 is 6. So you got negative 4, 6. Right there. You could plug in negative 5. If you do that in your head, negative 5 plus 3 squared is 4. Negative 2 times 4 is negative 8. Negative 8 plus 8 is 0. So it's negative 5, 0. You can plug in negative 2 and you get 6. And you can plug in negative 1, you get 0. And then you can kind of draw that very poorly drawn parabola. I just can't draw here. Okay. Now, if you're formally finding your x-intercept by letting y be 0, I know we already can see our x-intercepts here, but let's go ahead and formally find it. Let's let y be 0. And let's get rid of the minus 8, subtract 8 both sides. So you got negative 8 equals negative 2 times x plus 3 squared. Get rid of the negative 2. So you have 4 equals x plus 3 squared. And let me write it this way. X plus 3 squared equals 4. Now I have a perfect square, so I'm going to square root both sides. So x plus 3 equals plus or minus 2, because I square rooted both sides. And then I subtract 3 from both sides. So I have two answers, negative 3 plus or minus 2. Well, negative 3 plus 2 is negative 1. And negative 3 minus 2 is negative 5. So that's our x-intercepts, which we actually already saw. Negative 1, 0, negative 5, 0. We already saw those on the graph when we plotted the points, didn't we? That's how you find it algebraically. So, all right, let's go ahead and find the y-intercept by letting x be 0. Let's find our y-intercept by letting x be 0. Well, if x is 0, then we'd have 3 squared is 9. 9 times that negative 2 in front is negative 18. Negative 18 plus 8 is negative 10. So that's the point 0, comma, negative 10. So it's like down here somewhere. So this goes down and hits that 0, negative 10 on the graph as well. Okay. Well, if you have your standard form, this is our standard form, y equals ax squared plus bx plus c, then flip this here. I think it's worth seeing how you get to this. Let's take our standard form, and if you actually complete the square on that and try and put it in vertex form, I want you to see where this x equals negative b plus negative b over 2a comes from. What you do is you take an a out of the first two values, so you'd have b over ax now. You push the plus c out there, and then you'd complete the square on this. So what do you need to put in right there to make this a perfect square? Well, you take that b over a term, you cut it in half, and you square it. So b squared over 4a squared. So b squared over 4a squared. Well, what you really added was b squared over 4a. So you got to subtract b squared over 4a from the same side, because you don't want to add anything to the other side. And then you go ahead and then you factor this, and this factors into x plus b over 2a, and then you have this c minus b squared over 4a. So if you can see from my completing the square on this, there's my h. It's negative b over 2a. My h is negative b over 2a. So that's where you get that axis of symmetry from the standard form. So then you don't have to complete the square every time. You can just use the formula that the axis of symmetry is x equals negative b over 2a. So here it is, and we have our standard form. So instead of putting it in vertex form, we'll just say, oh, well, right away I know my axis of symmetry is x equals negative b over 2a. That's the middle of my graph. X equals, so my b is 6. So negative 6 over 2 times my a, well, my a is a positive 3. So negative 6 over positive 6 is negative 1. So I immediately put on my, if I was graphing this, I would put that negative 1 on my graph. And that's where my vertex is. And I also know my A is positive 3, so it's going to open up. And that's where I would start plotting points. My vertex is on the axis of symmetry. It has an x value of -1. Now, I know it doesn't ask us to graph this, but let's go ahead and kind of finish this one a little bit. So 3 times -1 squared plus 6 times -1 plus 1 is 3 times 1 is 3 minus 6 plus 1. I got -3 plus 1 is -2. So -1, -2 is my vertex. And I know it's opening up. And then I could just plot some more points to be a little bit more accurate about that. You know, I'd plot -2, -3. I'd plot to the right of -1, 0, and 1. I'd plot those points, and I could be a little bit more accurate with my graph there. Let's go ahead and do this next one. Y equals, so here's my standard form. Y equals -2x squared minus 5x plus 1. And let's go ahead and find the middle of the graph for this parabola, our axis of symmetry. -b over 2a. X equals negative. Our b here is -5. Our a here is -2. So we got 5 over -4, or -5/4. So when I'm drawing this, I'm -1 and a fourth. That's the middle of my graph on this one. So when I'm looking for my vertex, I'm plugging in -5/4. Now, when I plug in points to the left, I would just go to the next integer. So these won't be symmetric points on the graph. But it does open down. I don't know where it's at, but it is going to open down. But you can plug in some points from there. Okay, to find the axis. I'm sorry, to find the axis of symmetry. You know what? It does ask us to find the vertex. Let's go ahead and find the vertex, since we got to just plug it in here. So -2 times -5/4 squared minus 5 times -5/4 plus 1. So I got -2 times, that's 25 over 16, plus 25 over 4 plus 1. So I got -50 over 16. So I'm going to reduce that to -25 over 8 plus 25 over 4 plus 1. I'm going to get a common denominator. So 50 over 8 plus 8 over 8. So -25, oops, that's -25, plus 50 is 25. 25 plus 8 is 33/8. So our vertex is -5/4, 33/8. Vertex -5/4, 33/8. Okay, so it's up like 4 and an 1/8. So I actually drew this okay. It's up 4 and an 1/8. That's where that vertex is, and then it opens down. Okay. To determine here without graphing whether the quadratic function -2x squared plus 8x plus 3 has a max or a min. So I'm looking, first of all, does it have a max or min? Does it open up or down? Well, the a is negative, so I don't know where this is, but I do know it opens down. So I'm going to have a maximum. So I'm going to have a max on my graph, and it's going to occur where? It's going to occur at the vertex, okay, which is on the axis of symmetry. So since this is in standard form, what I'm going to do is I'm going to find in order to find this maximum value, I got to find the vertex. So I got to first find my axis of symmetry. I got to find the middle of the parabola first, because that gives me the x value of my vertex. So the axis of symmetry, x equals -b over 2a. Our b here is 8. Our a value looks like -2. So our axis of symmetry is -8 over -4, so +2. So let's pretend I drew this correctly as positive 2 right there. Let me do this one more time. So now I know the axis of symmetry is right here, positive 2. I don't know what the exact parabola looks like or where it's at, but let's say it's up here and we know it opens down, right? So we got to find that max value up there. In other words, we got to find our vertex. Well, we know the x value of the vertex is 2, so now we just got to plug it in. Plug the 2 in for x into our equation. Find the y value. And that's our max value. So it looks like we got negative 8 plus 16 is 8. 8 plus 3 is 11. So it ends up being 2, 11. That point right there is 2, 11, our vertex. And so the maximum value, that's the y value. Maximum value is the y value. How high is it? Maximum value is at the point 2, 11, but it is 11. Max value is the functional value there. All right, let's do a whole bunch of work on this one. Let's find the vertex, our axis of symmetry, the whole gamut. And then we'll go ahead and graph this thing. And it looks like we have it in standard form again. Ax squared plus bx plus c. So I'm going to start with my axis of symmetry. That's x equals negative b over 2a. And I'm going to plug in my b here is negative 6 over 2, and our a is 1. So it looks like we got 6 over 2. That's 3. 1, 2, 3. I'm going to put my dotted line on the graph x equals 3. That's where my vertex is. My vertex is at that x value of 3. So to find the vertex, I got to plug that in for x. So it looks like we got 9 minus 18, negative 9 plus 5, negative 4. So 3, negative 4 down here. And notice our a value was positive. Our a is 1. A was 1. A is positive. It opens up. So I know it's got to go up. I would like to plug a few points in. I think that's always nice. So I'm going to go to the left of 3 and to the right of 3. And I would plug those in one by one. You know, if I plug 2 in, I'd write them all out one by one. 4 minus 12, negative 8 plus 5, negative 3. So 2, I get negative 3. 1, I would get 0, and I could plug in the other side. It's going to mirror it because it's an exact distance away. And you're going to see that this opens up here. So you can kind of have the graph from there. Let's go ahead and formally find our x-intercept and y-intercept here. So to find the x-intercept, we go ahead and let y be 0. And we could plug it into our quadratic formula, x equals negative b. Or we can, you know what, I'm not going to do that. I'm just going to factor this. This is easier to factor. So it looks like 1 and 5. 1 and 5 are my, here they are right there and right there. We already knew that because I plotted some points and I got lucky and they happened to hit right there. But there's our x-intercepts across the x-axis. Now let's find our y-intercept by letting x be 0. If x is 0, it looks like we have y is 5. If x is 0, y is 5. So 0, 5. 1, 2, 3, 4, 5. It actually hits right there. So the graph will go through that point. 0, 5 as well. Now the last part of this does ask us for the domain. The domain of a quadratic, notice it encompasses all the x values. You can plug in any x value you want. You're going to have a y value. So in other words, negative infinity, positive infinity, or all real numbers, another way to say that. Now the range, on the other hand, the range here is, notice this is our lowest y value. That's our lowest y value because that's our minimum there. It goes from -4 and then it does shoot up. So from -4 it does include that and then it shoots up. So in other words, y is such that y is greater than or equal to -4 is another way to say that range on that set of all y values. Let's go ahead and do this one. Find the intercepts, axis of symmetry, domain, range, and graph of this one. So we have y equals ax squared plus bx plus c. Now notice this is just x squared and then the constant down here is -5. So when you're finding, number one, the axis of symmetry, negative b over 2a, our b is 0. Our a is 1, but 0 over anything is 0. So this just goes right down the middle, right? X equals 0. And then our vertex comes from that. Our vertex will lie on that axis of symmetry. And then I'm going to go right a couple, left a couple, and see what points those would be. But let's go ahead and plug 0 in to the equation for x. And it looks like we get -5, 0, -5. Well, we probably should have known this because from transformations, I know it looks like x squared, but that -5 just bumps it down 5, right? And then we would graph some other points. But let's go ahead and throw in, if I throw in 1, I got 1 squared -5, -4. If I throw in 2, 2 squared -5, and so on. You could kind of draw, oops, and it does open up. Our a is +1. Let's go ahead and formally find our x-intercepts by letting y be 0. So I'm going to add 5 to both sides. So I have x squared equals 5 and square root. So x is plus or minus the square root of 5. So my x-intercepts are square root of 5, 0, negative square root of 5, 0. In other words, 2 point something 0. Right, there it is right there, and negative 2 point something comma 0. There's our x and x-intercepts. Let's go ahead and find our y-intercept by letting x be 0. And so we would have -5. So 0, -5, which was our vertex anyways. There's our y-intercept. It's also our vertex, or our minimum point here. So the minimum here is -5. Our domain is all real numbers for all of these quadratics, so negative infinity, positive infinity. Our range, the lowest y value here is -5, and then it goes up. So from -5 up to infinity. Notice this one is kind of in standard form, but it's just got to change up these terms. I should have x squared first, -4x, and then +6. So my a is 1, my b is -4, my c is 6. So when I find my axis of symmetry, negative b over 2a, my axis of symmetry is -4 over 2 times 1. So I got 4 over 2, which is 2. Here's x equals 2. And then that'll be the x value for my vertex. So I'm going to plug that in. To 2, 4 minus 8, -4 plus 2. So the vertex is at 2. The vertex is at 2, comma 2. So right there. The a value is 1, so it's going to open up. I would plug in a couple points to the right, a couple points to the left, and then see what you get on that. You know, if you plug in 1, you got 1 minus 4 is -3 plus 6 is 3. Plug 0 in, you get 6. And then, of course, you could plug in the other side as well. but you're going to see that thing open up. Now let's formally find our x-intercept and our y-intercept by letting y be 0. And this, notice this does not factor. So you have to plug it into the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative 4 plus or minus square root of b squared minus 4a times c all over 2 times a. And notice I've got 16 minus 24. That's the square root of negative 8. So this is 4 plus or minus, let's see, 2i root 2 all over 2. In other words, 2 plus or minus I root 2. The x-intercepts are imaginary. Notice it never crosses the x-axis. It's above it, right? So they're imaginary. So I just say, oh, there's no x-intercepts on the graph, right? Because the graph is a graph of the real numbers crossed by the horizontal real number line crossed by a vertical real number line. So we don't have any real x-intercepts here. Does that make sense? So let's keep going and find our y-intercepts, which you probably already saw in the graph there. If I let x be 0, I end up getting 6. So 0, 6. And we had that up here on the graph. There's our y-intercept right there. The domain here, all real numbers. Domain, all real numbers. The range, here's our lowest y value. It looks like it's a y value of 2, and then it goes up. Right? And it goes up. So if you had one, by the way, if you had a graph flipped over, let's say you had one that went like this. And that was the point 3, 4. The domain is still all real numbers, but the range would be from negative infinity up to that 4 and a bracket on that, right? Because it's coming from all these y's up until 4. But when we're modeling quadratic functions, you guys, you're typically going to be looking for max min values as kind of your classic applications problem with modeling. So you're going to be looking for your vertex. So for example, let's look at this first one. Suppose the height of an object shot straight up is given by h, or h of t equals, I'm going to put the negative 16t squared first plus 512t, where h is measured in feet and t is in seconds. And so if you kind of get a little feel for this, notice our, ax squared, I know it's t and h, but our a is negative and our and so it's opening down. And you notice if at time 0 the height is 0, I don't know where the other time value is that it's 0, but what it does is, since it's opening down, it's kind of going like this, right? This is the projectile at time t and height h in feet and seconds. And so this is asking us, find the maximum height right here. What's your maximum height and the time? Time and the height in seconds, in feet. So find the vertex, right? Find the maximum height and find the time at which the object also hits the ground. So we'll hit the ground again over here, right? So that's what we're doing. So in other words, we're finding the x-intercept as well. Well, let's go ahead and find then, number 1, where's the vertex? Well, the vertex is on the axis of symmetry. X equals, in this case, t equals negative b over 2a. Negative b, or b is 512, 2 times negative 16. So t ends up being, what is that? Negative 512 over negative 32. Looks like I got 16. So this is a time of 16. At 16 seconds is when it has its maximum height. So let's go ahead and find the vertex now by plugging in t being 16. So, and find the maximum height. So it looks like I got 16 squared, which is 256 times negative 16. So negative 4096. And then 512 times 16 gives us 8192. So it looks like it's 4096 feet. That's the height after 16 seconds. That's our time in seconds. That's our height in feet. So at 16 seconds, it hit a height, this projectile, of 4,096 feet. So max height is 4,096 feet, and it occurs at t being 16 seconds. Okay. Now, when does it hit the ground? Oh, shoot, I don't have any room here. Let me erase some of this, give myself some room. Well, when it hits the ground is really asking us, it starts at the ground at time being 0, and then when does it hit over here? When does it hit the ground? So where's my x-intercepts? Well, to find the x-intercepts, you gotta let y be 0. I'm gonna factor a t. Let's see, and you know what? I think I can factor a negative 16t out, and I'll have t. Let's see, minus 32. Is that right? Negative 16 times negative 32 is 512. So negative 16t equals 0 and t minus 32 equals 0. We already know it starts at the ground. Excuse me, at time being 0. But this other factor saying at 32 seconds later, the projectile hits the ground again. Falls back down, right? So it hit its max height at 16 seconds, but then it hits the ground 16 seconds later, 32 seconds from when it was initially thrown up into the air, shot straight up. Okay. Daily revenue achieved by selling X boxes of candy is figured to be this. So there's our revenue, and there's our cost, right? So how many boxes must be sold to maximize our profit? Well, if you remember, profit is whatever money you bring in, your revenue minus your costs. So in this case, our profit function will be the revenue function minus the cost function. So let's go ahead and find our profit function. Our revenue is negative 0.04x squared plus 9.5x. I wrote that in standard form. There's our revenue minus, now we're going to do our cost, which is 1.25x plus 250. So we have negative 0.04x squared plus 9.5x. Distribute that, minus 1.25x minus 250. So negative 0.04x squared. Let's see, 9.5 minus 1.25. That's what, 8.25? 8.25x, and then minus 250. Now we're trying to maximize profit. Notice our A value is negative, so whatever this looks like, we're trying to maximize. We're trying to find the maximum for our profit function based on X boxes sold. We'll maximize our profit, right? What's that X value that we need to sell? Well, we got to find the middle of the graph. We got to find our axis of symmetry first. Negative b over 2a. So we got negative, our b is 8.25. And so this ends up being, let's see, 103.125. That's how many boxes. We'll round up. Instead of 103, maybe must sell. So I don't want to sell less than 103. So I'll sell 104 to make sure that we maximize this. Boxes must be sold to maximize profit. Profit, no E. Good grief, can't spell. So 104, right? So now I say, well, what is the max profit? Let's plug in to our profit function. The 104. And this ends up being 175.36. So that's our max profit. That's our max profit when we sell 104 boxes. Okay. All right, let's keep going here. For this one, we've got among all pairs of numbers whose difference is 24. Whose difference is 24. Find a pair whose product is as small as possible. Well, difference means subtraction, right? So if I have two numbers, let's call our two numbers x and y. I know their difference is 24. And we want to find a pair whose product is as small as profit. I'm trying to minimize the product, right? So the product, let's call it P equals so x times y. I'm trying to minimize their product. P being the product there. Okay. Well, let's go ahead and solve the first for either x or y, and then we'll substitute into the other one. So let's go ahead and solve for x on this first one. So we have x equals y plus 24. Now we're going to go ahead and plug that in for x over here. So now we get p equals y plus 24 times the y. So in other words, y squared plus 24y. Okay. So now what we do is we want to find our axis of symmetry from this. I know it's y is our input, p is our output, by the way, here. So y is kind of acting like our x here. So y equals negative b over 2a. So we got negative 24 over 2, negative 12. So negative 12 is where our axis of symmetry is. So let's throw in negative 12 to our equation y squared plus 24y. And that'll be our minimum product. So what's that? 144. 24 times 12 is 288. So I get negative 144 is our minimum product. Okay. And then let's go ahead and find our x. Our y is negative 12. If we know y is negative 12 and x is that y plus 24 right above, I got negative 12 plus 24. Our x is 12. So our two numbers are 12 for x and negative 12 for y. 12 for x, negative 12 for y. That will give us a minimum product of negative 144 with the restriction that their difference is 24. Their difference is 24. Not sure why this is not going away. Gosh, come on, go away. sorry guys, I don't know how to, there we go. Good grief. All right, here we go. Suppose we have 900 feet of fencing. You want to enclose a rectangular field that borders a river. So imagine you got this river and you've got this rectangular field bordering it. So I don't need fencing along the river, only 3 sides of this. Let's call it X, X, and Y. What's the largest area that could be enclosed? Well, we're given a couple, this, by the way, is our river, a piece of information. We have 900 feet of fencing, and you want to maximize the area. So what's our perimeter? Well, our perimeter is X plus Y, so 2X plus Y, and our perimeter is 900 feet. So far, this is what we do know, that 900 equals 2X plus Y. And then what we're trying to maximize is the area of this. Well, the area is length times width, so X times Y. We're trying to maximize that. So what I'm going to do is I'm going to solve for Y here. So subtract 2X from both sides. So I got negative 2X plus 900, or 900 minus 2X. And then I'm going to take that. I'm sorry, guys. My 900 minus 2X is my Y. I'm going to take that and I'm going to put it in right there. So my area is X times 900 minus 2X. So now I got 900X minus 2X squared. Let me go ahead and write it this way. Negative 2X squared plus 900X. And I'm trying to maximize this, right? Because this is something like this. I'm trying to find the max area, right? So I got to find my axis of symmetry. X equals negative B over 2 times A. So this ends up being 225. Negative 900 over negative 4 is 225. So I want to have 225 feet for my X values. And now let's find the Y values. So Y, we know Y is 900 minus 2X. So we get 450. Okay, so this is 225 by 450 is our area. Area is X times Y. So the max area is 225 by 450 feet by feet, which is 101,250 square feet. That's the max area. There we go. Max area. Length times width. Let's go ahead and write an equation for the graph shown. What I would do is I would do this with vertex form. I think that's the easiest way to do that. Because I would notice, oh, here's my vertex. My vertex, HK, my vertex here looks to be negative 1, 3. So I can immediately throw in negative 1 for H and 3 for K. So far this is what I have. Now, the only other thing I need is I need a value for A. I need a value for A. So what I'm going to do is I'm just going to take another point on the graph in order to solve for A. So I need to solve for A using an XY on the graph. Any other XY point. So I'm just going to take this one right here. I see 0, 5. Let's throw that in. 5 for Y. 0 for X. And now I can solve for A. And 1 squared is 1. Subtract 3 from both sides. So I have 2 equals A. So my A is 2. Now I know A is 2. And my HK was negative 1, 3. And so I can write the equation. in vertex form. Y equals A, x minus h plus k. So here's my equation in vertex form. I could also expand that and put that into standard form if I wanted to as well. That's not incorrect. X squared plus x is 2x. Distribute that. Combine like terms at the end. And that's the standard form. So either of those is correct on that. Thanks so much for watching. See you guys next time.